Today, lesson 5.8, linear relationships, and that kind of has been our focus lately, but our focus before today has been more on relationships that were proportional. Today we take a look at relationships that are not proportional. So we'll be creating linear relationships that are not proportional, as I just said, discussing the parts of that linear relationship. And why am I learning this? One of the big focuses today is on the starting value of a function. So please make sure you have those things filled in. All right, so now you know how to find the slope, or remember sometimes we call that the rate of change, or sometimes even the unit rate, given a linear graph. That's from previous lessons. From a linear equation. Linear equations are typically in the form y equals mx plus b, where m is the slope, or the rate of change, and b is the y-intercept, or a table with a linear relationship. And that's kind of what we talked about in the last lesson. So, remember, to find the slope, we're looking for the vertical length over the horizontal length, and in order to do that from a graph, we need two perfect order pairs. And hopefully we're at the point where we don't need to draw that triangle every single time, though we could if we want to, but we need to kind of get away from that. In this particular graph, the slope is 2/3. And then in the last lesson, we talked about how to do that via a table by looking at the vertical change over the horizontal change, which is the change in y values over the change in x values. As long as all of those simplify to the same value, that means we do have a linear relationship, and whatever those values are, that happens to be the slope. So that's kind of a quick summary of what we've talked about so far, including equations with proportional graphs, where that is the slope or the rate of change or the unit rate if there's context. And then we've also talked about the b value of the y-intercept, which in this case is 2. And the linear equation then from that particular graph is y equals 2/3 x plus 2. All right, so that was a quick summary of everything we've talked about so far. So in number 1, we have this table that represents the number of minutes and the number of gallons. And to be a little more specific with more context, Quinn is filling a swimming pool with water. The table below shows the number of gallons in the pool at a specific number of minutes. So let's go ahead and have all of you plot those 4 pieces of information. The x-axis represents the number of minutes. The y-axis represents the number of gallons. We know that from the table. So we've got 2,8, 3,10, and most of the time in my open math, you just need to plot 2 ordered pairs. So I just went ahead and went with that. And we were talking this morning about that. Usually if you see the dot tool in my open math, that's when you've got to plot all of them. If you don't only see the line tool, then you would typically only need 2. All right, so the first question is, what is the rate of change? Well, what is the rate of change? What is it?
4. Good morning.
Okay, we'll come back to that in just a second. All right, Nathaniel, let's try that again. What's the rate of change?
2.
It is 2. Thank you. So, look, remember, the slope of a line is its rate of change. And so we could find it from the graph if we wanted to. We have a vertical length of 2 and a horizontal length of 1. Or we could find it from the table. I like the fact that some of you were doing it from the table. But remember, if you're going to use the table, it's the vertical change, and that comes from the change in y over the change in x. But regardless, you should get a rate of change of 2. Okay? We always simplify the slope, or in this case, the rate of change. Now, so what that tells us is this, that the rate of change shows the pool fills at 2 gallons per minute. Okay? And that comes from the fact that we actually have context within this problem. So all of that is kind of what we've talked about so far. But we have this new thing called the initial value. Now, the initial value is actually something that we already know how to do. The initial value is related to the graphs or the tables y-intercept. Now we know the y-intercept from the graph is at 0, comma 4. And the b value of that is 4. The initial value is like taking both of those ideas and putting it in terms of the context that we have for the problem. So of course, right there is the y-intercept. So the initial value is 4, but what does the initial value represent? Well, what it represents is that at 0 minutes, the pool had 4 gallons of water in it. In other words, before Quinn started filling the pool with more water, it already had 4 gallons in it. That's what the initial value means. Okay? So there are going to be problems in the homework where I may only ask you for the numeric value of the initial value. That would be 4. And then there will be other problems where I may ask you what it actually means. So what it actually means or represents is at 0 minutes, the pool had 4 gallons of water in it. Okay? Fill in those blank areas, please. Typically, if I did ask you that, there would be drop-down boxes where the 0 minutes and 4 gallons would be. Okay? All right, so quick summary. The slope is the vertical length or the vertical change over the horizontal length or the horizontal change. You've got blank areas to fill in. The slope of a line is its rate of change. The y-intercept is the point where a graph crosses the y-axis. Sometimes you're asked for it as an ordered pair, like 0, comma 4. Other times you may be asked for the b value only, like b equals 4. And now the new thing, the b value of the y-intercept of a line is its initial value. So if I only ask for the numeric value of the initial value, it's just that b value. Okay? And so, linear equations are all of the form y equals mx plus b, where the rate of change or the slope is m. The b value can be thought of also as the initial value. So that's just sort of putting everything together. Okay? All right, so what I did next is I changed number 1 a little bit. So go ahead and read the part down below this problem in your notes and answer the 2 questions that are there. Okay? So, same kind of context. Quinn is filling his swimming pool with water. The graph to the right still shows the number of gallons in the pool at a specific number of minutes, but I changed the graph. So go ahead and answer both questions based on the change in that graph. So we are asked for 2 things. Number 1 is how fast is the water filling in the pool? And then how much water was in the pool before they started adding water? Well, how fast the water is going into the pool is just really technically finding the slope, because the slope is always the rate of change, or in this case, how many gallons per minute. So if you want to use your graph with a triangle, we have a vertical change of 5 and a horizontal change of 1. Therefore, the slope of that line is 5. Therefore, water is going into the pool at 5 gallons per minute. And you could have used any 2 perfect order pairs to figure that out. Then, how much water was in the pool before they started adding water? You're looking for the y-intercept. And it is, of course, the b value is found right there at 7. Okay? So, what is the slope? The slope is 5, right? What is the rate of change? The numeric value only. It's 5. That's the point that I'm trying to make here. The slope and the numeric value of the rate of change are always the same. Same thing with the unit rate for that matter. What is the b value of the y-intercept in this problem? 7. Okay? What is the initial value, the numeric value only?
7.
It's 7. Okay, now if I asked you for the ordered pair, of course, that would be 0, 7, exactly. All right, go ahead and turn the page and do number 2. So Sally has a summer reading assignment. She read some pages and then started monitoring her progress. First question was, how fast was she reading after she started monitoring? Second question is, how many pages had she read before she started monitoring her progress? Well, I'm going to use that point to figure out that question. She had read already 40 pages before she even started monitoring her progress. The numeric value of the initial value, of course, would be 40. 40 pages is the answer to the first part of that, because it did say how many pages. So what that means, or what that represents, is at 0 days she had already read 40 pages. Now the first part of the question, we're going to need to find the slope. So if I use that as my triangle, I have a vertical change of 60 and a horizontal change of 2. There are a couple of you who are still just counting the squares and not paying any attention to the numbers. You've got to pay attention to the numbers that are there, okay? And you're going to be doing some of this stuff in science this year as well. You've got to pay attention to the labels on the axes, and you have to pay attention to the numbers. But anyway, getting back to this, remember, the answer to this one is not just 30. It should be 30 pages per day. The numeric value of the rate of change is only the 30. All right, so she started, so this is just a summary of what is going on in this problem. She started with 40 pages and then read 30 pages per day. What linear equation represents this situation? Very good. Y equals 30x plus 40. So that's just kind of putting everything together. All right, everybody do number 3. All the parts, please. Number 3 says Ben had some money and then started saving money each week. How fast was he saving his money? And how much money did he have before he started saving weekly? Those are the two main ideas. So I can see from the graph that he had $40 before he actually started saving each week. So that's the answer to that part. If you're asked for the initial value, the numeric value only, of course, that is 40. And then we need to find technically the slope. And by the way, the initial value represents at 0 weeks, Ben already had $40. And so, using those two perfect order pairs, we have a vertical length or vertical change of 20 and a horizontal change or horizontal length of 4. Simplifying that and using the context within the problem, that would be $5 per week. That's how fast he's saving his money. If you're asked for the numeric value only, that, of course, would be 5. And then if you are asked for the equation, of course, that would be y equals 5x plus 40. Go ahead and turn the page and do number 4 all the way through. Number 4. The graph below shows the amount Leslie paid for a new cell phone and her monthly bill. We need to figure out what her monthly bill, what is her monthly bill for cell service and what was the cost of her cell phone. That, of course, right there is the initial value, so that must have been the cost of the cell phone, $200. Initial value as a numeric value only is 200, and then we need to find the slope to figure out what her cost is per month, and that looks like 100 over 2, so $50 per month is her monthly bill. As a numeric value only would be 50, and if you were asked for the equation, that, of course, would be y equals 50x plus 200. All right, so now let's kind of work backwards. In all the previous problems, I gave you a graph. This time I give you only context, and we have to create the graph. Well, we just have to really think about the two pieces of information that we need to create a graph. So we'll do number 5 together. Taylor is filling his swimming pool with water. It already has 9 gallons in it. So let's stop for a second. It already has 9 gallons in it. So what does that tell you then? What does that tell you? Yeah. What's that? Okay, so be a little more specific on that. The line is going to start at 9. Yes? 9 is the initial value. And I know that's what she meant. But what that means is that right here is the y-intercept or the initial value. And then the second part says, and is being filled at a constant rate of 2 gallons per minute. So what does that tell us? What does that tell us?
That the rate of change is 2.
Okay, so what am I going to do in terms of the graph? Because that's the first thing that we have to do here.
Every minute, the swimming pool is filled 2 gallons.
Okay, so technically what that means, the slope is 2, right?
Yes.
So a vertical length of 2 for every horizontal length of 1. So that would be our second point. Now, when we do these kinds of things in MyOpenMath, you only have to plot 2 points. So you would plot both of those, and then when you plot the second one, it will automatically connect the line or create that line for you. Okay? So that's what we need to dig out of context or a word problem. The initial value and the rate of change so that we can piece those things together to create the graph. So how many gallons did the pool start with? Well, we already kind of answered that. That's 9 gallons. The numeric value of that, of course, is 9, which means at 0 minutes there were 9 gallons in the pool, which created that point for us. Once Taylor started adding water to the pool, at what rate was it filling? Well, we already answered that as well. It was filling at 2 gallons per minute. And the numeric value of that is 2. And then from there we can rise 2, run 1, or vertical change of 2, horizontal change of 1. And there is our graph. All right, everybody do number 6 all the way through. So number 6, and by the way, the equation for number 5 was y equals 2x plus 9. I think most of us know that. Gabrielle is collecting coins. She has 3 coins in her collection to start with and plans to add 5 coins each week. So she started with 3 coins. The numeric value of that is 3. Which means at 0 weeks she had 3 coins in her collection, and that results in that ordered pair right there. And then once Gabrielle started collecting coins, at what rate was she saving? Clearly that is 5 coins per week. As a numeric value, that's 5. And that would give us that second ordered pair and draw our, technically that's a ray, but I'll continue to refer to it as a line, would look like that. And the equation would be y equals 5x plus 3. All right, quickly do number 7, all parts. All right, taking a look at number 7, the cost for a crew to come and landscape your yard is $100 per hour. The crew charges an initial fee of $200 for their equipment. How much did the company initially charge? Clearly that is $200. As a numeric value, that's 200, which means at 0 hours they charge $200, which results in that point being plotted. After the initial charge, at what rate did the company charge? That is $100 per hour. As a numeric value, that is 100. And then that will help us find the second ordered pair, vertical length of 100, horizontal length of 1, and then we can create our ray or our line, and that results in the equation y equals 100x plus 200. All right, number 8. On a bicycle, Leah rides for 2 hours and is 10 miles from her house. Well, that means or represents the ordered pair 2 hours, comma, you're going to have to wait until we're finished. 2 hours, comma, 10 miles. Now I know that because look at the x-axis. The x-axis has a label of hours, and look at the y-axis. It has a label of miles. So that's how I know it's hours first, comma, then miles. So that's what comes from that first piece of information. So we can plot that order pair 2, comma, 10. The second part of this problem, it says after riding for 7 hours, she is 35 miles away. So clearly, that comes from the ordered pair 7 hours, comma, 35 miles, which is right there. So the rest of the problem goes on to say use the graph to the right to help you with the rate of change and the initial value. Well, the best way to do this might be to draw a line through those 2 points. So at this point, I did not pass out rulers, so you might want to use the edge of something like your composition notebook. But I'll go ahead and do this one for you. It should look like that. So, how many miles away did she start? How many? Just tell me. 0. In other words, she started probably from her house. So 0 miles. The numeric value of that is 0. So that means at 0 hours, she was 0 miles from her house. And then it's after...
We know it's different for us.
Yeah, I know. I have a typo in your notes there. Nathaniel brought that up. So after she began her ride, I see a typo right there as well. What was her rate of speed? Well, that means we need to find the rate of change. So what would it be in this particular problem?
5.
5 what?
5 miles per hour.
There we go. Very good.
That's so slow.
If I asked you for the numeric value, of course, that would be 5. And the equation of that scenario is y equals 5x, which clearly, by the graph and by the equation, this is a proportional relationship. Okay? All right, one more problem, and then we're finished. Everybody do number 9. Number 9, a restaurant offers a delivery for their hamburgers. The total cost is a delivery fee added to the price of the hamburgers. One customer pays $8 for one hamburger, which of course would be right there as the ordered pair. Another customer pays $17 for 4 hamburgers, so that would be that right there. Based on this relationship, how many hamburgers are delivered to a customer who pays $20? Well, one way of doing this is creating your situation here, finding perhaps the delivery fee, which is the initial value, so $5, or 5 as a numeric value. Maybe finding the rate of change, which would be $3 per hamburger after you pay the delivery fee. As a numeric value, that, of course, is 3. And then you could take the equation and actually figure that out. So a customer pays $20. Well, I can see that the y values represent the cost. So if you took this 20 and substituted it right there, you could then take that and solve your equation for x, and that would tell you how many hamburgers they got. But what some of you did instead is you just went to your graph and you did something like this, and that's just as valid as long as your line is nice and straight. But regardless of how you did that, clearly it is going to be 5 hamburgers. Okay? All right, we are finished.